Hello class 7 students, welcome everyone. So today we'll be discussing about lenses. Okay, in the chapter light we'll be discussing about what? Lenses. Images formed by lenses. Okay, so what is a lens? First of all, you have seen spectacles, right? You have seen spectacles. Okay, what is present in it? It is a piece of transparent glass, right? Your spectacle, if you have seen a spectacle, then it is a piece of transparent glass. Okay, it is a piece of transparent glass. That means light can easily pass through it. If it is transparent, then light can easily pass through it. Yes. So what is a lens? A lens is a piece of transparent glass but with two spherical surfaces. Okay, it consists of two spherical surfaces. Two spherical surfaces. Okay. You might have seen magnifying glass, right? You have seen magnifying glass, right? So if you look at a magnifying glass, then you will find that in both the faces there is a transparent glass material. Yes, in both the faces, and that means in both the faces there is a spherical transparent surface. Yes or no? So magnifying glass is used to read very small print. It is shown in figure 15.21, as you can look. Yes, this is a magnifying glass. You might have also used it to observe the body parts of a cockroach or an earthworm. The magnifying glass is actually a type of a lens. Okay, so lenses are widely used in making spectacles, cameras, microscopes, telescopes, film projectors, binoculars. Okay, so these are widely used in making these materials. Yes. Okay. Now there are two types of lenses, two types of spherical lenses, you can say. One is your same in the case what we have learned in the case of mirrors, na? Spherical mirrors. Spherical mirrors are of two types, concave and convex mirrors. In the same way, lenses are also of two types. One is convex and one is concave. Okay, one is convex and one is concave. But what is convex lens? Okay. See, those lenses which feel thicker in the middle than at the edges are convex lenses. Those lenses which are thicker at the middle than at the edges. Okay. You have seen magnifying glass, right? See, if you touch the magnifying glass, you will feel that magnifying glass is thicker in the middle portion, but it is thinner at the edges. At the ends, it is thinner. Okay, so magnifying glass is actually made up of convex lens. Okay, and this is the representation of convex lens. See, thicker in the middle, thinner at the edge. Okay, and those which feel thinner in the middle than at the edges are concave lenses. Okay, those lenses which are thinner in the middle than at the edges are concave lenses. See, thinner in the middle, thicker at the edges. Okay, this is the representation of how you draw a concave lens. Concave lens you can find basically in spectacles only. Okay, those people who has a defect to look far objects. Okay, those people who has a defect to look far objects, they use concave lenses. They use what? Concave lenses. Okay. So what is mentioned here? Notice that the lenses are transparent and light can pass through them easily. Okay, lenses are transparent material with two spherical surfaces and light can easily pass through it. Because it is a transparent material, so light can easily be able to pass through it. Are you getting it? And you must remember this is how to represent convex lens and concave lens. Clear? Okay. Next, there is an activity in the next page, 15.9. Activity 15.9. See, this activity you have done in case of concave mirror also. Activity 15.6, if you remember. Activity 15.6, if you remember, you have done this activity earlier. Okay. But what you have to take in activity 15.9? In activity 15.9, you have to take convex lens in place of concave mirror. In place of convex lens, you have to take in case of concave mirror, you have to place convex lens, or you have to take convex lens. Okay. So take a convex lens or magnifying glass. If magnifying glass is available with you, then you can take magnifying glass also, because magnifying glass is also made up of a convex lens. So put it in the path of sun rays. Place a sheet of paper as shown in figure 15.23, just like this. Okay. You will see that you will get a bright spot on the paper. Adjust the distance between the lenses and the paper. You will get a bright spot on the paper. Bright spot of what? Bright spot of the sun. The image of the sun is formed on the paper. Are you getting it? So hold the lens and the paper in this position for a few minutes. Does the paper begin to burn? Yes, the paper will begin to burn. Okay. So why does this paper burn? When the image of the sun is formed on the paper, why does the paper burn? See, to understand this, there is a characteristic of, there is a property of a convex mirror and concave mirror both. I will explain you together. Okay, there is a property of convex lens and concave lens. Okay, see, when light rays are falling on convex lens, okay, then the convex lens converges the light rays. That means it bends. The light rays will bend inwards. Convex lens converges the light rays inwards. They will meet at a point. Okay. So a convex lens converges or bend inwards what? Bend inwards what? The light rays. See, light can easily pass through it because it is a transparent material. That is why light will not reflect here. Some of the light rays will reflect, no doubt. Some of the light rays will reflect, but major of the light rays will be able to pass through it. Okay, some of the light rays will reflect. Okay, no doubt. That is why we are able to see it, right? Light is getting reflected from the convex lens also. That is why we are able to see convex lens. But some light rays will be able to pass through it also. Okay. So a convex lens converges or bend inwards the light generally falling on it. Therefore, it is called a converging lens. But on the other hand, concave lens, what it does, concave lens will diverge the light rays. They will bend the light rays outwards when light is allowed to fall on it. Okay. So see, the sun rays, basically, the sun rays contain light rays also and heat rays also. Are you getting it? The sun rays contain light rays also and heat rays also. So the convex lens, what it does, convex lens converges the sun rays to a small point on the paper to form the image of the sun. So when a lot of sun's heat rays are concentrated on a small point of paper, then what will happen? The paper gets heated too much. Okay, and it will burn to form a hole. Are you getting it? The paper will get burned. Okay, because the convex lens will converges the light rays, heat and light rays of the sun on the piece of paper. Okay, clear? So what is this image known as? Because it is forming the image on the paper. What is this image known as? This image is known as what? Real image. See, the image which forms on the screen is known as real image. So here the image of the sun is forming on the paper. So this is a real image of the sun by a convex lens. Figure 15.23. Clear? Okay. Okay. We have seen in the case of mirrors that for different positions of the object, the nature and size of the image changes. So is it true for lenses also? Let us find out. You have seen, right, in the previous video that if you change the position of the object from the mirror, then the nature and size of the images got changed. Some of the images were real and inverted, and some of the images were virtual and erect in case of a concave and convex mirror. But what about in the case of lenses? What about in the case of convex lens and concave lens? So this we will find out in activity 15.10. Take a convex lens and fix it on a stand as you did with the concave mirror. Okay, just like this. On the next page it is shown over here. See, in page number 185. Okay, this is a convex mirror, convex lens used, okay, on the stand. Okay, so take a convex lens and fix it on a stand as you did with concave mirror. Place it on a table. Place a lighted candle at a distance of about 50 centimeter from the lens. Try to obtain the image of the candle on a paper screen placed on the other side of the lens. Okay, see, try to obtain the image of the candle on a paper screen placed on the other side of the lens. So you have to place the screen on the other side of the lens, just like this. But that means you have to place the convex lens in between the object, that is candle flame, and the screen. You have to place the lens in between these two objects, in between these two things. Okay, clear? You may have to move the screen towards or away from the lens to get a sharp image of the flame. What kind of image did you get? Is it real or virtual? See, as you can see, the image is forming on the screen, right? If you are taking a convex lens, the image is forming on the screen. So what type of image is it? Is it real or is it virtual image? It is real image, because the image is forming on the screen. And if you notice, is it the image is inverted or erect? See, it is pointed at the bottom, right? It is pointed at the bottom. So the image is what? Inverted. Are you getting it? The image is inverted. Okay. Now vary the distance of the candle from the lens. Try to obtain the image of the candle flame every time on the paper screen by moving it. Record your observations as you did in activity 15.7 for the concave mirror. See, on the other page, if you keep the object at a far distance from the lens, then you will get the image to be very small, smaller than the object. Okay, and the image is real and inverted. Okay, this is for this figure A. Okay, this is for this figure A. Okay, if you bring the lens closer to the object, okay, but not too close, then what will happen? You will get real image again. Okay, wait, I'll not write real image first. I'll write larger image than the object. Okay, larger image than the object. Then I will write again real image. Why real image? Because the image is forming on the screen. Yes, and the image is inverted again. Okay, the image is inverted. Okay, this is again for second figure. Okay, figure B. And the third time, if the object is brought very close, to the lens, what will happen? The image will be of what? The image will be of enlarged. The image will be enlarged. Okay, enlarged, larger than the object. Okay, the image will be enlarged. Then say it is real or virtual. It is virtual image, because the image is not forming on the screen. It is virtual image. Then the image is what? Erect. Okay, the image is what? Erect. Clear? So did you get in any position of the object an image which was erect and magnified? Yes, the image was magnified when, yes, the image was erect when it was brought very close or nearer to each other. Okay, nearer to the lens. When the object was brought nearer to the lens, then the image was erect and magnified. So could this image be obtained on the screen? No. Is this image real or virtual? It is virtual. So this is how a convex lens is used as a magnifying glass. When you take the convex lens or magnifying glass nearer to the letters which are written on the books or anywhere, then you will get the magnified image of the letters, okay, of the book. Clear? So in a similar fashion, study the images formed by a concave lens. You will find that the image formed by a concave lens is always to be virtual. See, this image is not forming on the screen. This is a concave lens is used. So in case of a concave lens, the image will be what? Virtual, erect, and smaller than the object. Clear? Image formed by a concave lens is always virtual, erect, and smaller than the object. Okay, so this is how the image is formed in case of a concave and convex lens. And with this, I will conclude the video. Okay, and the last topic is left from the chapter light, sunlight, white or colored. We'll discuss this in the next video. So that's all for today. Thank you and have a nice day.